In this example, we're going to let x be an integer, and we'll prove that if x squared plus x plus 1 is even, then x is odd. Now, in this proof, to assume that x squared plus x plus 1 is even isn't going to give us any useful information. We could write that as 2 times an integer, but then trying to manipulate that to get just x by itself, I guess we could use a quadratic formula. But the expression for x is going to be rather messy involved with that square root in there. It's going to be difficult, if not impossible, to show that x can be written as 2 times an integer plus 1. So we have a couple of options. We could either do a proof by contradiction, or we could show that the contrapositive is true. Both are going to involve very similar steps, but let me go through and show that the contrapositive holds in this example. And when you're doing a proof, proving that the contrapositive is true, you don't necessarily have to mention that to the reader, although you can if you'd like. But I'm just going to go ahead and suppose the negation of x is odd. So suppose that x is even. And then in our conclusion, we'll show that x squared plus x plus 1 is not even, i.e. that x squared plus x plus 1 is odd. So by supposing that x is even, then x is equal to 2 times k for some integer k. It's another way of writing there exists an integer k such that x is equal to 2 times k. You can use this for some language. And then we're going to take that 2 times k expression and substitute it into the x squared plus x plus 1. And then we just need to manipulate it until we get it into the form 2 times an integer plus 1. So doing some algebra, and then we can factor out a 2 from the first 2 terms. And then since k is an integer, 2k squared plus k is also an integer. Thus, x squared plus x plus 1 can be written in the form 2 times an integer plus 1, and so that means that it's odd.